guys. Today we will focus on the next 3 keywords, and the first one is universal set. So we start with universal set. And what is it? This is the set that contains all elements, and in Venn diagrams the universal set is represented by a rectangle, as you can see here. So we have rectangle, and the symbol for universal set is capital U, and then we have set X and set Y in the rectangle in universal. So every single element in X and in Y is also an element of a universal set. So in this case we have 1, 2, 3, 4, 5, 6 elements in sets X and Y, and we also have 2 elements outside X and outside Y, but they are elements of set U, universal set. So let's start with the first question, and we need to represent the following sets on a Venn diagram. And as you can see, we have U here, and we have 1, 2, 3, 4, 5, 6, 7 in a universe. A set 2, 3, 4, and B set 4, 5, 6. And as you can see, we have circles done already, and the universal set, what is a rectangle in here. And the symbol for universe is capital U. So as you can remember from the last video, we need to start with looking at set A and set B, and do we have any common elements, the same elements in set A and the set B, and they will go into the middle in the intersection of 2 sets. So we have 2, 3, 4, 4, 5, 6, so 4 is common in set A and set B. So let's start with 4 in the middle, and then we have 2 and 3 in set A, and in set B we have 4, 5, 6, so 5 and 6, and then we need to look at set U, universe. Set U contains all elements, so we used 3, 4, 5, 6 already, so what's left? 1. It's outside A and B, but it's still in universe. Then 2, we have 2, 3, we have 3, 4, we have 4, 5, we have 5, 6, 6, and 7. So 7 also goes outside set B and outside set A, but it's still in universe in the big rectangle. So take this example down to your copy, please. And the next keyword for today is complement of a set A. So the complement of a set A is the set of elements in the universal set U that are not elements of A. So look at the photo here, and you can see a universal set in here, and we have set A inside. So complement of a set A is everything outside A. As you can see, this region is shaded in yellow, so everything outside set A, and the symbol for complement is A with a little comma on the top. This is the symbol of complement, and take the definition down in your copies, symbol and the diagram as well, and shade it in color. So how does it look like in our Venn diagram? So let's do the example number 2. We have universe, set A, set B, and first we need to represent the sets on a Venn diagram. So let's start looking at set A and set B. We have 4 is common, so we need to put 4 in the middle, in the intersection of set A and B. Then 2, 3 in set 4. As you can see, this is set A, not only this part, but full circle is set A. And the same full circle is set B, not only this part. The full circle, I need to remember about it. It's really common mistake in junior cert exam and every single test. And then we have 4 in set B and 5, 6. Now we need to look at universal set. So as you can see, we've used 2, 3, 4, 5 and 6. So we need to place 1 and 7 outside A and B. So 1 and 7, still in universal set, but outside A and B. And now we need to list the part B, we need to list all the elements of A complement. A complement means everything outside A set, everything outside. So cover set A, and what's outside? Outside set A we have 1, 7, 6 and 5. So let's write it down. Remember, this is also a set, so we need to use curly brackets. So we have 1, 7, 5 and 6. Then we need to list all the elements in B complement. So now this is set B, and B complement means everything outside B. So what's outside the B? This is outside the B. So outside B we have 2, 3, 1 and 7. Okay, now what if we have A union B complement? So look at our sets. We have A union B. First, A union B means everything in A and everything in B. So if we have A union B, we need to list 2, 3, 4, 5, 6. But in this case, we have A union B complement. So everything outside A union B. What is outside A union B? So outside A union B, we have 1 and 7. Still a set, so curly brackets, 1 and 7. And maybe one more, A intersection B complement. So first of all, look at A intersection B. A intersection B is in here, so this is the 4, only 4 goes in the middle. And now, what's outside this little region? So outside we have 3, 2, 1, 7, 6 and 5. And this is A intersection B complement. So 2, 3, 1, 7, 5 and 6. That's it. So take it down please into your copies. And the last keyword for today is set difference. So the set difference of sets X and Y, the symbol is X/Y, is the set of elements that are in X but not in Y. So this is the symbol X/Y, everything in X but not in Y. And as you can see on our diagram, everything in X but not in Y. So we need to get out of Y set, and this little part in yellow is everything in X but not in Y, and this is the set difference. So take the next definition down to your copies with the symbol in color and draw a nice diagram please. Okay, now look at our Venn diagram. We have set A and B, and now we have 1, 2, 3, 4, 5 in set A, 2, 4, 6, 8 in set B, and we need to start with representing all elements on our Venn diagram. And then we need to list all the elements in A but not in B, and the second one is B not in A. So let's start with looking at our set A and B, look at the elements and do we have any common elements in both sets. So 2 and 4, and let's put 2 and 4 in the middle. Then in set A we have 1, 3 and 5. In set B 2, 4 and 6 and 8, and this is done, this part is done. And the next part is listing all the elements in set A but not in B. This is also a set, so curly brackets, remember that. Looking at our set, this is set A, this is set B, this is set difference. So everything in A but not B. So this is B. Everything in A but not in B. This is the part we need. 1, 2 and 3. Everything in A but not in B. So 1, 3 and 5. Right? Now we need to look at set B and set A again. Everything in B but not in A. So this is this part. Everything in B but not in A. So we cover set A, and 6, 8 is left. 6 and 8. That's it. So take it down in your copies, please. And this is our last example number 4. So let's try to complete the Venn diagram first, and then using all the symbols we've met so far, list all the elements. Okay, so let's start with looking at set A and B. Look at the elements. Do we have any common elements? So we have 2 and 4 in both sets, so we need to place them in the middle, straight into the intersection, 2 and 4. And then in set A we have 1 and 3, and set B just 8. Now we need to look at our universal set. So we've used 1, 2, 3, 4, 5, 6, 7. We used 8. So just 5, 6, 7 go outside A and B, but still in a universe. So we have 5, 6 and 7. Great. This part is done. So now we need to list all the elements in set A, but not in B. So looking at our sets here, everything in A, but not in B. So 1 and 3. Okay. Now everything in B, but not in A. Everything in B, but not in A. So in B we have 2, 4, 8, but 2 and A and 4 are also elements of A. So only 8 is in B minus 8. Okay. Now we have A union B, and A union B, as you remember from the very first video, means everything in A and everything in B, union. So 1, 3, 2, 4 and 8. 1, 3, 2, 4 and 8. And then the next one is A intersection B. Intersection means in the middle, between A and B. So between A and B, common elements are 2 and 4. 2 and 4. Great. Now, number 5. And the first part, we need to break it down. It's much easier. So the first part is union, A union B. And we can use the previous sets. So we have union and then minus intersection. So we have 1, 2, 4 and 8 in union, but we need to take away 2 and 4, get out of 2 and 4. So this 1, 3 and 8 are the elements we need. So 1, 3 and 8. Great. Now we have A union B complement, and the same. A union B, everything in A and B. So complement, this little comma on the top, means outside the union. So outside the union we have 7, 6 and 5. Okay. The next one, everything outside the intersection. So the intersection is here, 2 and 4. And we need to list all the elements outside the intersection. So this is all outside the intersection. So we have 1, 3, 7, 5, 8 and 6. Seven, 8, 5 and 6. Okay, and the last one is A, everything in A, but not in B, complement. So look in here. A minus B, it's 1 and 3. So this little part, everything in A, but not in B. But complement means everything outside. So this is everything outside A minus B. So we have 7, we have 2, 4, 8, 5 and 6. Okay, so take this question down into your copies, please, and try to do them by yourself, and then you can check with the video. And this is part B of our example number 4. So looking at our diagram filled in from example number 4, we need to focus on cardinal number. So hash A, hash B, hash U and so on. So hopefully you all remember what is cardinal number. So in this case we need to just state how many elements are in a set. So hash cardinal number means how many elements. So how many elements are in set A? Looking at set A, we have 1, 2, 3, 4. Remember, this little part is also part of set A. So we have 4 elements in set A. Then we need to find number of elements in set B. So look at set B. Also, this little part is part of set B. 2, 4 and 8. So we have just 3 elements in set B. Then we have how many elements are all together in a universal set. So 1, 2, 3, 4, 5, 6, 7, 8. Remember, universe. This is a set which contains all the elements. So elements and the rectangle. 1, 2, 3, 4, 5, 6, 7, 8 elements. Then the next question is, how many elements are in A complement? So everything outside A set. So we have 1, 2, 3, 4 elements outside A. And the next we have all the elements, number of elements in A union B. So again, A union B means everything in A and B. So we have 1, 2, 3, 4, 5 elements. And the last one, everything in A but not in B. So everything in A but not in B. 1 and 3. So we have just 2 elements. That's it. So make sure you have all questions taken down in your copy. So after watching this video, you should be able to explain me what is the universal set and the symbol for universal set. So universal set is the set that contains all elements, and every set is a subset of the universal set. And in Venn diagram, universal set is represented by the rectangle. Then the next keyword we've met today, complement of a set A. So everything outside A, and the symbol for complement of a set A. And the last one, set difference. So in this case we have everything in P but not in Q, and this is the little yellow part. And the other way, Q minus P, so everything in Q but not in P. So see you tomorrow.